This is January 08, question 6. Making reference to energy transfer, state the meaning of the term electromotive force of a battery. Now we've had this a few times before, so if you just learn off the definition and put it in, and it's energy changed to electrical energy per unit charge passing through the battery. And that's worth 2 marks. A source of electrical power with an EMF of 4.16 volts and an internal resistance, small r, supplies a current of 0.8 amps to an external resistor of resistance 4 ohms as shown in figure 6.1. So in figure 6.1 what we have is a battery or cell. It has its internal resistance R here. There's a current of 0.8 amps flowing around the circuit, and there's an external resistor of 4 ohms connected in the circuit. It then says calculate the internal resistance of the source. Now if we know the total current coming from the battery, we know that the total resistance in the circuit is R plus 4, and we know the total EMF. So if you use V is equal to IR, the V that we're using is the E is the EMF 4.16, and that's equal to 0.8 on R plus 4 ohms. And so that's equal to 0.8 R plus 3.2. And so we can just work out what R is equal to by taking 4.16 minus 3.2 equals 0.8 R. Okay, so I'll just run through that again. V is equal to IR. The total V is the EMF of the battery, which is 4.16 equals 0.8 times total resistance in the circuit is R plus 4. And that's equal to 0.8 small r plus 3.2 when you multiply out the 4 and the 0.8. To solve that, then bring the 3.2 across, it becomes minus 3.2. That's equal to 0.8 R. And therefore, R comes out to be 1.2 ohms. Okay. Calculate the power dissipated in the 4 ohm resistor. And since we know the current flowing through it, it's just a simple matter of using P is equal to I squared R. So that's very straightforward, only 2 marks available. P is equal to I squared R equals 0.8, which is squared, multiplied by 4, and that gives you 2.56. And it's measured in watts. And that's the end of that question.